In this video, you will learn about circuit breaker pattern and how to implement circuit breaker pattern in our project using libraries like Resilience4J and Spring Cloud Circuit Breaker. So without any further delay, let's start the video. So what is circuit breaker pattern? A circuit breaker pattern is like a general best practice which is used in the real world distributed systems whenever our applications are calling some remote services or remote APIs or remote services. So in our project, if we take our project as an example, we have many services here. We have our product service, order service, and inventory service, and all three services can be accessed through the API gateway. And what can happen sometimes is any of these three services can go down or respond very slowly because of some performance issue on the database or on the network level or for whatever reasons. So when this kind of things happen, what happens is when the API gateway is calling the other service, for example, product service, which is responding very slowly, API gateway has to wait for the response for the product service. As more number of calls are in waiting state, waiting for the response from the product service, what can happen is the API gateway can also gradually degrade its performance and can also be crashed. Right. So this is one of the issues which must be addressed when we are working with microservices or maybe distributed systems. And the other case is product service can also be crashed or maybe down, and the API gateway, whenever it receives any request, will keep calling the product service even though we know that the product service is down, right? So is down and unreachable. Right. So what we can do is we can use the circuit breaker pattern, which is very similar to the circuit breaker we find in our homes, which will protect our electrical appliances. So in general, whenever you get a huge power spike at your home, what will happen is the circuit breaker will be tripped and the circuit breaker will block all the incoming power to the electrical appliances, right? So in the same way, the circuit breaker in the distributed systems, what it will do is whenever it recognizes that there are large number of calls which are failed due to the large number of API calls that are failed, what it will do is it will block all the outgoing requests from our service to the service which is not responding. So if we take our project as an example, so if the product service is unreachable or maybe slow, the circuit breaker will switch on and it will block all the requests from API gateway to the product service. So in this way, we can also implement the circuit breaker between the communication between order service and the inventory service. So if the inventory service is not working for any reason, the circuit breaker which is configured in the order service will block all the outgoing requests to the inventory service. So in this way, we can also save a lot of network calls, and it will also improve the performance because this can lead to cascading failures. That means if the order service is calling inventory service and maybe the inventory service is calling some other service, right? And this some other service is the actual reason for the failure. So then you are making some unnecessary calls all the way from API gateway, order service, inventory service, and then the other service, right? So what we can do in this scenario is we can already stop making calls from the API gateway itself if we know that the response from the order service we are receiving is not valid one. Right. So that's the circuit breaker pattern. So we can implement the circuit breaker pattern using a library called as Resilience4J. So I'm on the homepage of the Resilience4J library. So you can see that the Resilience4J is a lightweight fault tolerance library designed for functional programming, provides also higher order functions with circuit breaker, rate limiter, retry, or bulkhead. So these are all the resiliency patterns. Circuit breaker is one of the resiliency pattern which makes sure our application is resilient enough to external failures. The Resilience4J also comes with a rate limiter which makes sure that our application is not making a large number of calls to the external service. We also have a retry pattern and the bulkhead pattern. The retry pattern mainly deals with making sure that whenever there is an error, it will also retry the same call to make sure that it is not a one-off issue that is causing the failure. Right. So we will have a look at some of these patterns in this tutorial. So we will also use Spring Cloud Circuit Breaker to implement the resiliency patterns using Resilience4J. So this is Spring Cloud Circuit Breaker is like a library which will help us to integrate this library, this Resilience4J and the circuit breaker pattern easily into our applications. So you can see that it provides an abstraction across different circuit breaker implementations. So Resilience4J is one of the implementation to provide the circuit breaker feature, and the other one is also Spring Retry. You can also use Spring Retry to use a circuit breaker pattern. So now without any further delay, let's go ahead into our project and implement the circuit breaker pattern in our project. So now I opened the API Gateway project, and as I mentioned before, we will start implementing the circuit breaker pattern first in the API Gateway, and then we will also look at the order service and see how we can implement the circuit breaker pattern over there. So for the first thing, what I'm going to do is I'm going to open the pom.xml file, and inside the pom.xml file I'm going to add a dependency, two dependencies actually. The first one is going to be the dependency for Spring Cloud Starter Circuit Breaker Resilience4J. So this will add the Spring Cloud Starter Circuit Breaker and also the Resilience4J libraries to our project. And the second library is going to be Spring Boot Starter Actuator. So this actuator dependency will provide us the endpoints which we can use to track the metrics of our application. So this is useful also when you want to see the status of the circuit breaker. You can refer to the endpoints, the health endpoints, which is provided by the actuator, and determine in what state the circuit breaker is in our application. So after adding these two dependencies, make sure to click on the Maven icon to the top right side corner if you're using IntelliJ to force IntelliJ to download the dependencies. And after that, what we have to do is we have to configure the Resilience4J in our API Gateway project. So for that, I'm going to open the application.properties file, and here I'm going to add in some properties. So I'm going to explain, don't worry, I'm going to explain all of these properties in detail. So the first properties, the set of properties is going to be the properties for the actuator endpoints. So here we have this property management health, circuit breakers enabled true. So as the name suggests, we are going to enable the circuit breaker feature in the actuator health endpoint. So for that, we're going to we should define this particular property and set it to true. And we are also asking actuator to enable all the endpoints, to expose all the endpoints that it provides. We can also, of course, narrow it down to some specific set of endpoints. So for now, as this is like a demo project, I'm going to expose all the APIs, which are all the endpoints which are there in the actuator. And I also added some property management endpoint health show detail always. So this particular property will make sure that we have all the health details about the application which are displayed always. These are the three endpoints for actuator. Next comes the properties for the Resilience4J. So this is where we are configuring our circuit breaker. We have this Resilience4J circuit breaker configs.default. So this is the property path. Whenever you want to apply the Resilience4J configuration as a default settings, you can use this path. And after that, we have this register health indicator property, which we also need to set it as true because we are also enabled the circuit breakers on the health endpoints. So if you also add this register health indicator, then it will make sure that the information is synchronized correctly. Then we have the sliding window type. That means the sliding window makes sure that how we want to determine the criteria to switch on the circuit breaker. So what we want to do here is we want to count the number of requests which are coming to the API gateway, and if the request threshold has crossed a certain limit, then we want to switch on the circuit breaker, right? As we are using the criteria to count the number of requests, I'm going to provide the sliding window type as count based. So if I just click on this, control click on this particular value, you can see that we have the sliding window as also time based. So you can also configure the sliding window to be activated after a certain threshold of time. So for now, we are just going to use the count based because this is the most reliable way for us to introduce the circuit breaker. So after that, we also have to define the sliding window size. So what is the number of request criteria we want to determine to activate the circuit breaker? So for that, I'm going to provide the size as 10. So it will count 10 requests at a time, and it will determine if we need to switch on the circuit breaker or not, right? And next comes the property failure rate threshold. That means if we set it as 50, that means in the 10 requests, the circuit breaker will be switched on whenever the 50% of the calls are failing, right? So in our case, if we set the sliding window size as 10 and the 50% of the calls are failed, that means 5 requests are failing, then the circuit breaker will be changed, will be opened, right? And we also have this property wait duration in open state as 5 seconds. So for this to be able to understand this point, I have to explain you the different states of circuit breaker. So yeah, this is how the different states of circuit breaker looks like. So by default, the circuit breaker will be in the closed state, and whenever the circuit breaker is identifying a failed calls, then it will be changed to the open state. That means circuit breaker is active and it is blocking all the calls to the external system, right? And after the in open state, it will of course it cannot stay in open state indefinitely, right? So it also has to allow some of the calls to make sure that if the request is reachable now reachable or not. So for that, it will we have the state as half open. That means we can configure circuit breaker to go from open to half open state after a certain time limit, right? For example, after 10 seconds, after 1 minute, whatever time limit, we can configure the circuit breaker to go from open to half open state. So in the half open state, the circuit breaker will still allow some of the calls, but not all calls, to make sure that to know if the other service is working or not. If the other service is still failing with the same errors, it will go back to the open state. That means it will continue to block all the requests to the external service. And if the circuit breaker identifies that, okay, then we are now getting a successful response from the external service, it will move the status back to the closed status. That means all the requests to the external service are now not blocked by the circuit breaker, and they are just transferred, and they are sent to the external service as it is. So these are the 3 different states when we are dealing with the circuit breaker. So now we are going to configure the time limit, make sure that the circuit breaker stays in the open state before going to the half open state. So for that, the time limit, we can configure it using the wait duration in open state as 5 seconds. So after 5 seconds, the circuit breaker will move from the open state to the half open state. And how many requests the circuit breaker will allow in the half open state, we can also configure that using the permitted number of calls in half open state as 3. So for my example, I'm going to make sure that I'm going to allow 3 calls to the external service in the half open state. If any of these 3 calls are failing, then I will make sure that then the circuit breaker will go back to the open state. And if any of these 3 requests are passing, then the circuit breaker will be set as closed. So at last, we have this automatic transition from open to half open enabled. So we are going to make it as true, because we want to, after 5 seconds, we want the circuit breaker to go from open to the half open state. So that's why we have on to add this property as true. So next up, we have timeout properties for Resilience4J. So here you can see the property Resilience4J, time limiter configs default, timeout duration. We have provided the timeout duration as 3 seconds. So we're going to use timeout whenever Resilience4J is detecting that the external service is not returning the response in the determined amount of time. So that means if the external service is not returning any response in 3 seconds, what Resilience4J will do is it will fail the request then and there, and then it will increment the counter for the circuit breaker. So if this kind of timeout happens 5 times in a row, as per our configuration, then the circuit breaker will be open, and all the further calls to this particular endpoint, the slow endpoint, will be blocked until the circuit breaker is in the half open state. This is for the configuration of timeout. So the next thing we are going to do is we are going to change the configuration of our routes to include circuit breaker. So what we did is we defined the circuit breaker configuration for the project, but we have to assign this configuration for the routes itself, because as if you remember, we have configured the routes manually inside the routes class. So we have to define now the circuit breaker if I assign the circuit breaker to this particular routes. One thing I've added also added is I've added a bean called as fallback route. So if you remember, this is we are using Spring Cloud Gateway MVC, and this Spring Cloud Gateway MVC, we are using the Web MVC functional endpoints. So using the functional endpoints, using Spring Web MVC functional endpoints, you can define a route using the route method, and then we can call the get method and pass in the path of the get method. So what this will do is it will create a get endpoint similar to how we do in the Spring MVC world. We create usually a REST controller and then the get mapping method, right? So similarly, we can do all this very easily using this functional endpoints. So inside this get method, the first parameter is going to be the path, and the second parameter is going to be the lambda of the request. So whenever a request is received, we are going to execute this particular statement and then return the response, right? So what we are doing is whenever we receive a request, we are actually sending out a status as HTTP service unavailable with body service unavailable, please try again later. So this is far better than showing some blank response with error status. So whenever our circuit breaker, whenever the request is failing, we will be actually showing this error message, right? So coming to the actual configuration itself, what we can do is we have to define the circuit breaker as a filter. So we can define that by adding the .filter method here, and I'm going to add circuit breaker filter functions .circuit breaker, and the circuit breaker is going to take first parameter as the ID. So the ID is going to be product service circuit breaker, and the second parameter is going to be fallback URL. So whenever we receive a fail request, the circuit breaker will be calling this fallback URL. As we have already defined the fallback route with the endpoint path as fallback route, so what I'm going to do is I'm going to define a URI with the help of URI.create, and here what I'm going to do is I'm going to forward this request using this forward keyword to the fallback route. So that's all you need to do to configure our routes to use this circuit breaker. So let's copy this this particular method call, and I'm going to update all the other routes. So I'm going to just below the route method, I'm going to copy this filter with the circuit breaker filter function. So I'm going to change the ID as product service swagger circuit breaker, and now I'm going to again copy this and then do the same thing also for the order service. So that's all you need to do to add the circuit breaker to the routes. And one last thing we can also do is we can define the retry from Resilience4J. So I'm going to add a property for Resilience4J retry properties, and here I'm going to type in circuit breaker resilience4j.retry.configs.default.max atoms is going to be 3, and after that I'm going to wait a maximum duration of 2 seconds. So what I'm going to do is before the timeout occurs, I'm going to retry the slow request for a maximum of 3 times, and then I'm going to wait for 2 seconds for a maximum of 3 times, and then I'm going to retry only after waiting for 2 seconds. So if the external service is not returning a response in 2 seconds, then I'm going to retry this with a maximum of 3 times. If the retry is also not working, then the timeout will kick in, and then we'll actually open the circuit breaker. So this is all you need to configure the Resilience4J and circuit breaker patterns in your API gateway. All right, so I've forgot to add one more property for our Resilience4J circuit breaker configuration. So the property is going to be I'm going to add a property with name minimum number of calls. So this minimum number of calls is the minimum threshold to consider a circuit breaker. So if, for example, if we have the sliding window size of 10, and if we don't define this minimum number of calls, the circuit breaker we expect the circuit breaker to open if half of this number, if 50% of these requests are failing, right? So if we don't define this minimum number of calls, what will happen is a circuit breaker will not open until all the requests of the sliding window size are failing. So if I don't set this amount, if they don't set this property, then the circuit breaker will not open until all the 10 requests are failed. It will not take the failure rate threshold into consideration. So to avoid that, what I'm going to do is I'm going to add the minimum number of calls option as 5. So what the Resilience4J will do is it will start consider the failure rate threshold once it reaches a minimum number of calls 5. As we have the failure rate threshold as 50%, then if the number of calls which are failing is 5, circuit breaker will now go into from closed to open state when 5 calls are failed. Now what I'm going to do is I'm going to start the API gateway application, and then we are going to test this implementation of the circuit breaker for API gateway. All right, so now I'm going to open the Postman HTTP client, and here I have the call to get all the product information from the product service. So this call is of course made through the API gateway, and the first thing I'm going to do is I'm going to request a new access token from the Keycloak server, and I'm going to click on proceed and click on use token. So now I'm going to before making a call to the product service, I have already stopped the product service. So if I make one call to product service, so if I make a call to the product service, then the request will fail. So before doing that, let's open the actuator health endpoint of the API gateway. So for that, I'm going to open the URL http localhost 9000 actuator health, and I'm going to make use of the token which I have requested just before, and I'm going to click on send. And you can see that the circuit breaker status is unknown. So that means none of the circuit breakers are yet registered, so because we didn't make any request yet. So what I'm going to do now is I'm going to make a call to the product service, and you can see that we got the response service is unavailable. And if we now check the health endpoint again, you can see that the status of the product service circuit breaker, the health is up. But if you go into the details, the state of the circuit breaker is closed, right? And you can see that the number of failed calls is 1. So as the threshold of our number of failed calls is 50%, and we have to make a minimum of 5 calls, I'm going to make 4 successive calls now, as I've already made 1 call, 1, 2, 3, 4, and click on send. And you can see that the status is circuit open, and the state is now in the open state. And now after waiting for 5 seconds, if we try to check the health endpoint again, so I think 5 seconds is already passed. So if I click on send, you can see that the circuit breaker is going to the half open state, right? This is because we have the configuration to wait a maximum of 5 seconds in the open state and then go back to the half open state. So that's why the circuit breaker in the half open state, and if there are any past requests, now successful requests going to the product service, then after minimum of 5 requests, the circuit breaker will go back to the status of closed. So now I'm inside the product service. I'm going to start the product service application. If I click on send for the get product request, you can see that the response is fine. We are getting the response from the backend. And if you check the health endpoint, you can see that the status is still half open, right? So now let's make 4 other calls, successful calls, 1, 2, 3, 4, 5. And if I check now the status, that the product service breaker is in status up, and it is now in a closed state. So the next part we are going to cover is to test the timeouts. So to simulate a timeout, what I did is to inside the product service get all products endpoint, I've added a thread.sleep, a wait for 5 seconds, so that it simulates a slowly responding API. So I just add this thread.sleep for 5 seconds, and then I restarted the product service application. And now if you open Postman and again make sure you get a new access token and use that token, and if you call the products service, you can see that we are getting a slight delay, of course, because there is also a retry and timeout. It's happening on the API level, API gateway level. So this is one request. So now let's make 4 other requests, because this is the minimum number of calls for circuit breaker to activate. So for the 5th request, you can see that the response is instantaneous. We are not getting any delay because the circuit breaker is now went to the open state, is now in the open state. And if you stay in this open state longer, then you will be redirected. Then the state will be changing to the half open state. So now if I want to check the actuator health endpoint, you can see that now the circuit breaker is in the half open state. So now if I try to send another request, you can see that now the circuit breaker is in state open. Now if I go back and then remove this thread.sleep and then restart my application, and now if I try to call the get product endpoint, so I get the response pretty quickly. And now if I check the actuator health endpoint, you can see that now the state is closed. Alright, so in this way you can see that we can also implement the timeout feature, so that our application, our API gateway is not affected even with the slow performing services, and there is also not degradation of the user experience in this way. Alright, so now it's time to implement the circuit breaker pattern inside the order service, mainly with the communication from the order service to the inventory service. So for this, the implementation is very similar, but there are only some small changes. So for that, I'm just going to walk you through the changes. So I will not be doing the live coding for this part. So the thing we have to we have to do is we have to make sure first that the 2 dependencies, for the first one is circuit breaker Resilience4J, Spring Cloud Starter circuit breaker Resilience4J, and the Spring Boot Starter actuator dependencies are added to the order service pom.xml file. And after that, inside the application.properties file, so I'm going to add the same properties which we have added inside the API gateway, but the only difference here is in the property. Instead of adding the property resilience4j.circuitbreaker.configs.default, so that is the property prefix we added for API gateway. So if I open the API gateway, you can see that the prefix is resilience4j circuit breaker configs.default. But now what we want to do is we want to add this to a particular instance of our REST client. So that's why we are going to use the prefix circuit breaker.instances.inventory, and also the name of the client is our REST client is also inventory. So that's why I added the name as inventory here. So to actually apply this changes, what we have to do is we have to open the inventory client, and what I did here is to add 2 annotations. The first one is the circuit breaker annotation, and the next one is the retry annotation. It's important to provide the name of the circuit breaker, the name of the Resilience4J instance as inventory, because this name should match with the instance name we have provided in the properties file. And again, in the API gateway in the API gateway configuration, we have added the fallback route by providing forwarding the request to the fallback route and then sending the response as service unavailable. But here what we will do instead is we will handle this more gracefully by providing a fallback method, and inside this fallback method we will be just logging this information that we are not able to access the inventory service, and we are just going to return the inventory as false. That means the order service will identify that something is wrong with the inventory service, because because the order service will not able to accept any orders because the inventory service is not working, but we will not face any degradation of the user experience. So this is for the circuit breaker and the retry annotations, but we have another thing we have to implement, that is the timeout. We can use for the timeout, we can use the time limiter annotation from Resilience4J, but to implement that we need to complicate the things a lot. So instead of adding this time limiter, what we can do is we can add the timeout to the REST client itself. So we can just configure the REST client to have a connection timeout and as well as a read timeout. So if we don't get a response back in a stipulated amount of time, then the REST client will automatically terminate the connection. So to do that, what we can do is we can open the config package and we can open the REST client config class. And in here, I've added some configuration for the REST client. So I've added for the REST client builder, I've added the .request factory method here, and inside that I'm going to call the get client request factory method. This is the method I created, and inside that we are calling the client HTTP request factory settings class, and we are using the default option of the client request factory settings. Instead of defaults, we can also use other implementations, because there are many implementation of the client HTTP request factories. So if you go into the request factories, you can see that in the get method, it can support multiple request factories. The first one is HTTP components client HTTP request factory, a Jetty client request factory, and OK HTTP3 and simple client HTTP request factory. So we don't want to bother ourselves by picking one of them. So I will just make use of the default client HTTP request factory by just calling the defaults variable, and then we can construct our timeout and the read timeout by calling the with connection timeout, with connect timeout, and then with read timeout methods. And to this methods, I am just going to provide a duration of 3 seconds, because I want to have a connection timeout and as well as the read timeout as 3 seconds. So once this is done, what I'm going to do is I'm going to get the client HTTP request factory from the HTTP request factories class, and then this is going to return and then set the request factory before we build the REST client. So once we configure all of these things, then we are ready to test our changes. So I'm going to start the order service application now. So once the application is up and running, we can go ahead and test our changes. So I'm going to submit an order. So first I'm going to get a token from Keycloak. I'm going to use the token and then click on send. You can see that we are getting a 500 error response. This is because we are not able to because the inventory service is not working, but we are able to gracefully handle this inside the fallback method. So you can see the log cannot get inventory for SKU code iPhone 15, and the failure reason, we also have the failure reason, the reason of the failure. So we have IO error on get request for the inventory service URL with the reason as connection refused. So instead of seeing the reason as connection refused, we are now seeing the error 500. Of course, we can make it even more better by not throwing a runtime exception, but maybe doing some other fallback logic here. So that's not necessary for our tutorial. So I'm just going to keep this simple. So in this way, you can configure also the order service with the circuit breaker functionalities. I hope you learned something new in this tutorial, and I hope you liked the content. I will see you in the next tutorial. And until then, happy coding techies.